Hello, Tahira, can you hear me?
Yes, just you might have to get a little bit closer.
Yeah, okay. Yeah, thanks for the reminder. Yeah. Okay. So what about now?
Yeah, it's good now. Thank you.
Okay, let me confirm that here. Okay. So if it go a bit far, so you remind me, please. Okay.
Okay.
Okay, good. So I will try my best to go as fast as I can, but you have to slow me down if you see that I'm going faster than I should. Okay. Uh,
Okay.
Typically, this is not the case in all the times, but we are limited in time, as you know. So
Yes.
let me see. Let me think. So at the moment, while I'm starting to share with you, I think you started to see the slides. Um,
Yes.
while I'm doing so, are you able to open the IntelliJ? Did you ever write any code in the IntelliJ before?
The first few classes, yes.
Okay, so you please open it and keep it open until we go to that step so that, because I mean, sometimes it takes time. So try to, as much as we can, we get the maximum use of time. So at the previous class or the last class, we actually stopped here, right?
Yes.
Okay, do you have any question or should we proceed?
We can proceed.
Okay, good. So do you know what is an operating system is?
The operating system, yeah.
Okay, so you are using an operating system, which is Windows at the moment, but there is another examples of operating system. So there is Mac OS and Linux. So this is an example of other operating system. If you are using an Android phone, so they are using Android operating system. So this is an examples of an operating system. But what is the importance of an operating system? So without the operating system, we are not able to open any application that we have. So without an operating system, you're not able to open Zoom. You're not able to open the web browser. So the operating system deals with the hardware, and there is a lot of details that is in this step here. So here, there is a lot of things, a lot of benefits, a lot of features that the operating system is doing for us. And for example, memory management, they do something like called multitasking. They taking care of peripheral devices, which is the mouse, keyboard. So when you press something on the keyboard, who takes the information from the keyboard itself and store it inside the memory or the RAM? So operating system is doing all of this for you without you feeling it. So again, this is just only a single slide for that, but in the IGCSE computer science, we actually take a whole big chapter just only about operating systems. Okay, so when we ever have a chance later, maybe we can talk more about it. That will help you not only here specifically in Java, you will not need that information, but in other subjects, you might need to understand more about the operating system. The basics of the operating system will help you to understand the other subjects that you're talking about. Like, I mean, there is other subjects that you are taking at the moment. You will find them more easier if you understand more about the operating system. So at the moment, we will stick to what we're having at the moment. So how, I mean, okay. So the one who knows the hardware very, very well is the operating system. He deals with the mouse, with the keyboard, with the RAM, with the CPU. He deals with all of those without us knowing it. We just give him some clicks, or we click on an icon, or we even move the mouse here and there, and he do the things for us without us feeling it. So far, did you understand what I'm saying? Do you have any questions?
Yes.
Good.
Not for the moment.
Okay, so if you don't have an operating system, you are not able to open Zoom. And that should be clear to you. Not Zoom, not a web browser, not any other application. So all of those application is dependent on the operating system. And there is a version for the Zoom that can work on Windows, and there is another version of Zoom that can work for the for the Mac OS, for example. So it means that not because you have a Zoom, then you are able to open it and make it run on Mac OS and Windows at the same time. No, every operating system have its own version of the programs. So far, is that clear?
Yes.
Okay, that's good. So the same, we consider Java. I mean, Java it's a tool that we use it to build application programs. So at the end of the day, what we're going to write, we're going to construct application programs, but we do it in a customized way. So we will choose what our application will do. Zoom, you don't have a choice. And also using Java, you are going to have a direct communication with the CPU and even the RAM. When you are dealing with a Zoom, for example, or even a web browser, you just only limited by mouse clicks of what you can do with the Zoom. The one who really control is the company that builds the Zoom. So they write the program using either Java or any other programming language to produce a Zoom. But they have full control of what the application can do. They can do things under the hood. You cannot see what they are doing. Okay, they can send your information to their servers. Also, you cannot know that. But when you write your own application, you control everything inside it. So using the Java and writing instructions directly to the CPU get you in full control of what's happening around in your program. Is that clear?
Yes.
Okay, perfect. So let us move to the next. So I would say I would try to skip as much as I can these portions, because this is I mean, I will try. I mean, if I don't skip, I might miss other parts that can come in the exam. So I have no choice. I have to skip parts. Okay. So he's telling about the benefits of Java and the history, and that is totally not very important to us. So I will move to, yeah, that is, yeah. So do you know what is this part and what is this part? This is almost a fixed part that come with every Java program. This portion and this portion, I would say every Java program have it. This got no single change. This part got no single change. So the entrance or the start or the basic construction that you need to use to be able to run a Java program is you need to write a public class and you give it a name. This name, it is you that can choose it. You can choose it to be welcome. You can choose it to be other name. That is totally fine. But you have to start with public class. And then also public static void main. It is marking the starting of where our code should start to run. And that is also totally fixed. There is no single change here. Okay. Tell me your questions, please.
The only questions I have is like, what does static and void mean in this situation?
So, okay, static void. So, okay, every program or everything that we're going to write will have something called return type. And static, I would say in this construct, is it possible that you allow us to explain static later? Static is slightly complicated. It will come later, but so I would say just as simple as we say, static is something that stay in the memory and stick to the memory. This is just an initial definition, but I have to build on top of that later. So you will have okay, let me just first call this. This is called class. This part is called the class, and you will learn that more in something called OOP. Okay, so later in your syllabus, you have to learn something about the OOP, and then you will understand why he actually saying public class. Okay, so and we will understand more about the public and the static and the void later when we build or when we learn about writing methods. So actually this line is defining the entrance method. Okay, so again, it doesn't change. Sometimes I'm able to pass input to my program at the moment, and in most of the entry Java programs, they do not pass inputs to the program. So this part, you will not do it or use it at the moment. But when we learn about methods, I will explain in details what this can actually mean. So because you will learn it in details in method, like I'm telling you. So at the moment, allow me to move on to the most important things. So I would say, if it is possible, I would like you to actually look at this code and tell me, did you ever write something similar to that or not?
Yes.
Okay, so we call this a statement. So every line of code that we going to write in Java, we call it a statement. We mark our statement with semicolon. So the CPU or the computer in general is a dumb thing, which means that if we don't mark the end of our statement, the Java will never know where it should stop reading. Just remember that Java does not understand anything about the English alphabet. It only understands about the ones and zeros. So as long as it doesn't see the semicolon, it will never know that the statement ends here. Okay, so we need a few things to run our programs. The print statement, like what you are seeing here, is the programmer friend. Always, I mean, whenever there is a lot of things that's going to happen inside the computer memory that you cannot see with your own eyes. The only way for you to understand and to see what's happening inside the memory is to actually use the print statement. So I will always call this is a print statement. So if I tell you write a print statement, it means that you have to write this. This is something that you have to memorize, which is system.out.println. So there is another, or never mind, let us not talk about other things now. Let me focus on this. Print line will print this line on the screen. And not only that, it will press enter after it prints the line, which means that any time that you'd like to do another print after this line, it will print it on a new line. So as my assumption, you write welcome to Java, and then you write end. So if you write another print statement here, like system.out.println, like that, and you put that here, which means that, sorry, it's not exactly here. It should be somehow, let me try to clear this. So it should come in this place. So this should be printed here. So if I do that, I will first on one line write welcome to Java. On the second line, I will write end. Why? Because I'm using here print line. Print line means that I print every line on separate from the other line, from the other lines around, which means that this welcome to Java will act as if you press enter after that. If you press enter on a line, it means that it move you down to write on a new line. Does this make sense?
Yeah, it's like a line break.
Okay, yes, exactly. So did you write ever something like that before?
Yes.
Okay, so you don't need to know to see how it works, right? Or do you?
No, it's okay. This one I know.
Okay, that's good. So let me move to the next. So he explained here that you're still able to write Java programs using a notepad. So you do, I mean, that is not common. This is not something that is very common. It is possible, but it is not common. So he is telling that you can open a notepad and open the Java code and you're able to edit it in a notepad. This is a very painful situation because notepad does not produce colors in front of your eyes. So it does not color the certain keywords that is fixed. It does not mark this, how to say, statements. So this is actually system.out.println belong to the Java. Okay, it should come on different colors other than welcome to Java. So welcome to Java, this is something that you input as a user, you want to show to the user, but they should normally come on a different colors. In Notepad, there is no colors at all. So everything is the same color. So that is also sometimes confusing. And that will not help you to detect errors easy. So did you ever need to use a new Notepad when you are writing Java code?
No.
Okay, so you actually, and even to me, this part, this should be skipped because we have an IDE. The IDE is IntelliJ in your case, and we should stick to that because we don't have time to actually go through this. And to be frank, I never see any exam questions that come on this thing here. He just want this might be a little bit important. So I will also try to summarize as much as I can. So we call this code here, okay, as a source code. And that can be saved on a disk. And when we save it in a disk, we save it in a file that have an ending .java. Does this make sense to you?
Yeah.
Okay, so how, okay, first of all, so this is, you create and modify the source code, and we say we are able to save this Java file into the hard disk, which is okay. Permanent storage, it means that we close the computer, we open the computer another time, we are able to open the same file again without any issues. Okay, so we use a compiler, which means that we need to translate the source code to another format. But in the Java, we do not directly convert. We know the translator take high-level language, convert it to machine code. Do you remember from yesterday?
Yes.
Okay, but in the Java, it is slightly complicated. They make it complicated because they want to make the Java programs portable. So what they do is that they do not convert the source code directly to a machine code. They save the source code, they make an initial conversion using a compiler. So the compiler, as we know, it look at the whole file, it check if there is errors or no, and then convert the whole file into a format. They call the format, it is a bytecode. It is a middle between the source code and the machine code. Machine code is ones and zeros. So the bytecode is not understandable by the machine yet. It is not ones and zeros. It is in a format that is still readable by human. This is how it looks like. Okay, so normally, like, this is 1% chance that you ever have questions about how the bytes code looks like. Okay, so there is more important topics in Java than to really try to understand here. But what you should understand is that you use a compiler to convert source code to bytecode. The bytecode is also can be stored on a disk. It is a middle format between the source code and the machine code. And then we take the bytecode and then we run it inside something called, I would say, call it a JVM. Did you ever hear about JVM before?
Yes.
So it is a Java virtual machine. So for Windows, we have a Java virtual machine. For Linux, we have a Java virtual machine. We are able to take the bytecode and we run it on the Windows Java virtual machine, and it will convert the bytecode into ones and zeros. Just be aware, the ones and zeros that is in the Windows is different from the ones and zeros that is in the Mac OS or the Macintosh or Apple in short. Okay. And if you would like to run the same Java program on an Android phone, you need another JVM. So every processor need a specific format or arrangement of the ones and zeros. The ones and zeros still ones and zeros, but the format, I mean, ones and zeros, I mean, at the end of the day, I told you before, we take this command or statement, we translate it into an instructions, simpler instructions that is understood by the CPU. The instruction of each CPU is different from one another. Inside the Android phone, you will see them using not Intel processors. They use a different type of processors. In the Apple, they use also different processor from the Windows. So for every processor, there is instructions that is different from the other type of processors. So it means that the final translation process need to depend on the CPUs that you're going to use to run your program. So that's why they are proud and saying that the Java are able to run, are portable, and they make it portable so that you don't have to change your source code, but you have to only change your Java virtual machine. So inside the Android, you install the Java virtual machine that is suitable for the Android. So it will translate your bytecode into a machine code that is understandable by the Android operating system and the processor there. And if you go to an Apple, you install the Java virtual machine that is compatible with the Apple, and it will do the translation in a way that the output of the machine code will be understandable to Apple. Is that understandable by Windows? No, it is only understandable by Apple. And we in the Windows install a different Java virtual machine that is understandable by the Windows only. Does this make sense, or it's complicated?
Yes, it makes sense. Yes.
Okay. So can I say that your understanding is like 60 or 70%?
Yes.
Not below that, right?
No, no, no.
Okay, that's good. So I explain here. So I will actually, he's explaining this in a different way, but let us move again to the most important parts. He's also explaining here about, if you have any question, you stop me. So I see that I need to move in front. So he's telling here how we can write commands to be able to execute a Java program. And that is not really interesting to us. We're using IntelliJ at the moment, so we will stick to that. Let me see here. Class name. Okay. I see class name also. I'm able to skip. Also here, the main method we should skip at the moment. We explain about the statement, which is printing. We explain about the terminator. Okay. So a very important thing that we should note, there is certain things, like I told you before, that we are able to control and we are able to use it on our own. For example, the welcome, it is something that we name it on our own. And the things that we name and we choose on our own should not ever use the reserved keywords that's specified by Java. Public class is words that is reserved by Java. We should never use them. Public static void, we should never use them in the names. So we should never give a this welcome cannot be a class. We cannot remove this and write class. We cannot remove this and write public. This keywords is reserved by Java to be used in certain places and certain arrangement. In our naming, we should not name things on the using the reserved keywords. Definitely, we have to use public class, but we use public class here. And when I tell you that we have to choose a name for our class, which means that I'm using here the name like I choose. So I might call it tahira, for example. Okay, so that is my choice, but I cannot use a reserved keyword for that. So I can name it any other keyword or name that is not reserved by Java. Does this make sense to you?
Yes.
Okay. So also, since we are here, whenever we do not want the Java to translate certain lines and execute them, we mark them with 2 slashes, which means that this is English keywords that is only for commenting for our own understanding. We use comment to explain the code. So when you become a programmer, then the more comments that you put, the more clearer your program become to the person who read it after you. When you become a programmer, you will deal with many other teams or person or colleagues when you are writing your code, especially if you are working for a big company. So the best thing is that other people are able to understand your code. And when you also read other people's code, you should understand it. And that depends on the programmer who writes. If he write very good comments, it will make your job easier. Does this make sense so far?
Yes.
Okay. I know we did not go into the practical part yet, but be a bit patient. I think once we finish this slide, we will start to be able to write some codes of Java. So let me tell you this. So every curly braces that we open, we have to close it. So this is an opening and this is closing. If I open here curly braces that belong to the public class, I have to close it here like that. If I don't, you will face a lot of errors that sometimes is very hard to understand or even to solve. So be very careful from this. So, okay, and another thing, the thing that we said that is fixed always, which is the void main, which is the entrance or I mean, it mark the start where Java should start executing our programs. So this is a statement, it needs to be executed. If it is executed, you will see on the screen, welcome to Java. If I put 2 slashes like that, there will be no execution. The Java will consider that this line is a comment and is not worth executing, which means that you will not see an output on the screen. Does this make sense to you?
Yes.
Okay. So we have here a curly braces, an opening curly braces, and we need to close the opened curly braces. So if we have 2 opening here, we need 2 closing curly braces here. This is very important. Is that clear?
Yes.
Okay. So let me explain this. So again, I told you that the computer is actually a dumb thing. You always need to mark it the starting and the ending for him. So I would say this double quotation is always used to mark text. So if you would like the computer to actually print something on the screen and you want to print it as it is without even touching it, you put it in between double quotation like that. If you put a starting double quotation and you forgot the ending double quotation, the computer will not recognize that the text have an ending. So it will consider this and any lines that come after it as a text. So, and that will produce an error in your code. So Did you ever try to remove the double quotation? Did you ever try to do that?
I have forgotten to put it.
Sorry again?
I have forgotten to put it a few times.
Okay, and you see the error comes out.
Yes.
Okay, so you are aware of that, so we don't need to do that together, right?
Yes.
Okay, that's good. So we talk about curly braces. Okay, so normally, okay, this that we said we will later try to clarify once we reach methods. This we call it a method, and typically methods they use parentheses like this. Okay, and yeah, that's one thing. And you also have to understand not only in these lines of code that we consider void main as a method, we also consider the print statement or the line that allow us to print things to the screen as also a method. It is a ready-made method that is given to us from the Java that when we use it, we give it an input, and whatever input that we give, it printed to the screen. So am I able to change that to anything? We can, instead of saying welcome to Java, we can say welcome to Tahira world. We can say welcome to Taylor. We can say anything. It is up to us. So the Java allow us to put anything in between the parentheses here, okay, and we decide if we would like to put a text to print it out or even an integer or anything else. We will see that later also. So at the end, every method need to have this parentheses. So this method have its own parentheses. At the moment, you don't need to learn anything about this. You only need to know that any Java code that you need to write must have a class, and the class must have a name, and the name you are able to change it as much as you can. You can put it welcome, you can put it main, you can put it any name, it doesn't matter. Okay, the most important thing is that you don't use a reserved keyword. This line of code specifically with the open curly braces and the closing curly braces is something that you need to memorize. The code inside, you don't need to memorize it. This, and this only, 1, 2, you need to memorize it. This is always the same. So if he asks you to write a Java program, then you need to write this and this, and you need to memorize that if you are afraid to forget it. Okay, whatever inside here, this is based on our understanding and based on the requirement of the exercise or the question. So this you should not memorize. This at the moment is an example of a code that runs, but it doesn't mean that every code we run must have this. Does this make sense, or it's complicated? Is it getting complicated?
It makes sense.
Okay.
It's still understandable for now.
Okay, that's good. So, okay, let me check here. Appropriate comments. Putting appropriate comments is also, yeah. Okay. So we talk about comments, and you know already that comments is something that explain what the code does. You can put it anywhere, not only in one place. Anywhere you want to put a comment, just use slashes. Let me also talk about naming. So let's assume that we do not want to name our class welcome. Just now we said public class, and we say welcome here, right? And then we open a curly braces. This welcome we are able to change. So I'm able to put compute expression. Just note here that I mean, this is a recommended way of capitalizing the letters. It doesn't mean anything specific. It is just a recommended thing. It make it meaningful and understandable that you try to capitalize every start of a word. So compute is a word, expression is another word, and we put them together. So it is good. Instead of just writing E small here, you write E capital. It make it markable and understandable. So far, does this make sense to you? This is only just a naming. So if you would
Yes.
like to say welcome world, so I make this capital and this capital, and then I make it like that. Okay, clear? We move to the next.
Yes.
Okay, that's good. Okay, so we have three types of errors that we are able to face. Definitely, we need to write more code to be able to really detect, this need practiced so that you can recognize. Syntax errors is something that you forgot to actually write, or you did not write. So if, for example, the print line have two parentheses like that and semicolon. If you forgot the semicolon, this is called syntax error. If you forgot to put this parenthesis, the closing parenthesis, this is a syntax error. If you have the curly braces like that, and then you forgot to close the curly braces, this is called a syntax error. So this is the language that the Java understand. If I speak to you in English and I tell you a word in Bahasa Melayu, for example, in the Malayu language, so you will become blur. You will not understand me. So you need to tell me things in the language that I understand. And we need to tell the Java the commands that it's programmed or designed to understand it. So it is designed that every curly braces, every open curly braces, it need to have a closed one. If it doesn't see it, it considers this a syntax error, and it will be detected by the compiler, and the program will not run. Does this make sense?
Yes.
Okay, so now we will look at the runtime errors and the logic errors. So a runtime error is not detected by compiler, so he will not detect that error initially. He will allow you to run, and then he will tell you, oh, I'm facing problem. So in the syntax error, he will not even run. So here we are actually missing the double quotation. So he removes the double quotation by intention, so that if you run that, the compiler will show an error. So the compiler will show an error, and it means that he didn't even run the program. Now look with me, what is the runtime error? So a runtime error is not a syntax error at all. Everything is okay in this, and it will run, but once it runs, it will not be able to print 1 divided by 0. So in computers, we are not allowed to have a division by 0. So you cannot divide any number by 0. And that is called division by 0 error or exception. Okay, so this is called a runtime error, because it will, logically, if we look at how the construction of the syntax of Java is totally understood, it's totally clear, there is no problem at all. But when we try to execute that is an error that will only appear once we try to run. So it will, if you say, will the compiler show us an error here? No, he will not show us an error. He will compile that to bytecode, and then he will try to run it, but he will fail. He will fail to actually produce an output, because he will fail in dividing these two numbers. Did you understand me?
Yes.
Okay, so if you remove the 0 here and put maybe 2, will you see a result? Yes, you will see a result. So it is only the 0 dividing by 0. That is a problem here. Does this make sense?
Yes.
Okay, why I feel that you are I know that this is a theoretical part, and you seem to be like you would like to have practical part, I believe.
No, it's not that. I am how can I say this? Whenever I'm getting the information, I try to translate it in a way that I understand. Like yesterday, when we were saying high level language and I was saying human level language. So I'm translating the things that you are saying to make
Okay.
it make for me to memorize it better.
So, okay. And also forgive me. I mean, in the typical relaxed classes, I mean, when we are not rushing for an exam, I always typically ask the student if they really understand. But
No, it's okay. I'm
sometimes,
understanding it.
yeah,
I'm understanding it.
okay. So, okay. What I want to say here that a logic error, it means that the code is okay and there will be no runtime errors, but the result will not be as you should expect. So this is a conversion between Celsius and Fahrenheit. And another example of a logic error, typically the USD, if I would like to convert one USD, it will give me around, I don't really remember the exact conversion rate, but it will give me around 4.45 MYR, Malaysian ringgit. So, okay, if I do the calculation here and I make a program that it will calculate, and instead of just putting the conversion rate as 4.45, I put 3.35. So that is something that we can call as a logic error. So the program will still produce an output, but you will find the output, it is not as it should be. So we call that kind of errors as a logic error. So the logic of the program does not make sense, or the output of the program does not make sense. The calculation is wrong. You make a mistake in the calculation and or the equation that calculate the thing for you. So you could be maybe same, okay, if you go to a store and you would like to buy something, so what they do is that in order for them to calculate the price inside their computers, so they will say that they have a purchasing price. Sorry, that is wrong here. Let's say purchase. So assume that is 10 ringgit. And then they add the profit and assume that the profit is 2 ringgit. So this is, and they have a tax, and the tax, let's say it's 1 ringgit. So in order for them to show you the price that you need to pay, they need to add all of those and show you the result of this. So this should make the final price that you should pay as a buyer 13 ringgit. If they do mistake in the calculation and instead of putting profit as 2 ringgit, they actually put it 0.5. So yes, you will be able to see an output, but the output will make them in a big trouble. It will make them somehow not be able to cover their costs. So yes, you will have a result, but the result, you will find it that maybe here it's giving 11.5. So we are 1.5 ringgit lesser than we should be. So that is a logic error. Okay, so far, does this make sense to you? Or
Yes,
is it difficult thing?
it makes sense. Yes.
Okay, so do you notice that if I write these two statement, one will print Celsius 35 is Fahrenheit degree, and on the second line, it will do this calculation and print the final number on the screen. So when we have a print statement like that, this print statement will get evaluated first, and on a later lectures or not on a later slides, we will see how this kind of calculation is done, because it have a method. It is not just simple that we start from here, or no, it have a way. So we will learn that, but at the end of the day, we will not show on the screen this kind of 9 divided by 5 multiplied by 35. No, we will not see that. We only see the result. Did you ever do something like that before? Did you ever write a code that do a calculation before?
I haven't written it, but I've seen it in class.
Okay. Do you mind if you have, do you have your IntelliJ open so far?
Yes.
Do you mind if you write this line of code? Once you write it, you can share it with me. Is that okay?
Yes. Yes.
Okay, that's good.
Okay, this is it, I think, no?
Okay, is it possible yet you're able to share?
It's I'm sharing now, but I guess it's taking time.
Okay, that's good. That's good. So do you face any errors so far? Tahira, can you hear me?
The only error, I think I wrote Fahrenheit wrong, and then the calculation.
It's not correct.
It's giving a warning.
Okay, let me try to wait until I'm able to see what is happening on your screen. Yeah, okay, that's good. So, okay, the most important that, okay, so forget about the warning. Um, okay, can you first hover? Can you hover with the mouse on this? Let me check. So, okay, can be replaced by 35. Okay, never mind. It's okay. Totally fine. What we are doing here, Fahrenheit. Forget about Fahrenheit. Also, that's as long as it's running and producing an output. That's actually great. So,
Okay.
first of all, we know that any error that you write here, it will be printed exactly as it is. So we know that the text actually is something that is going to print it as it is. And we would like also to see, so if you come here and add the plus, can you do that? come here. Yes, add plus and write 100, for example. Okay, can you run? Okay, so now I showed you a way that we are able to use to mix in a print statement, to mix between text and numbers. So I'm able to add a number here and it will be printed out as it is, like if you can see here, okay, just by using plus. So even though this is a text and this is it's an integer, and we will learn about integers later on the next slides. But who take care of that is Java take care of that, because just we put a plus sign inside a print statement. He will convert everything that we put into a text for us, and he will print it out in the screen like that. Does this make sense? I mean, is it clear?
Yes.
Okay, so what if you don't want this calculation to actually be printed out? So there is one way. If we come here and come here and we put double quotation here and a double quotation after 32. So before the bracket here, before the second bracket, you put a double quotation and you come after 32 here. Yes, now run, please. So now you see that the equation is written as it is. He doesn't execute it. So the computer, again, is dumb. If you mark something as a text, he does not think about it at all. He does not try to execute it or make a calculation out of it. And that is how, if we would like to clear, to print the equation to the screen, this is how we should do it. Just put double quotation here to mark the start, and another double quotation to mark the end of our text. Does this make sense so far? Is it okay?
Yes.
Okay, so
Yes.
should we move to the next?
Yes.
Then stop sharing and let me continue sharing. So, okay. We will also try to skip as much as we can, but again, let me try to understand from you, what is a variable?
A variable is an empty space where we can input any value to be represented.
Okay, not bad at all. That is not bad at all. So a variable is a reserved place in the memory that we are able to store values inside. Yes, and the kind of values is decided by something called data type, and we will learn that. So at the moment, as we saw before, okay, I mean at here at least, y is a variable, and we have something like a calculation or an equation here. Not a calculation, it's an equation, because if you don't know x, then you are not able to execute that line. So he tell you here x equals 0. So if x equals 0, he would try to do this calculation, which means that he will multiply the 2 by 0, and then he will add that to 5. So 2 by anything multiplied by 0 give me 0, right? So this evaluate to 0, and then the 5 remains still the same. We add the 0 to 5, and then this result in 5, and the 5 is going to be stored inside the y, which is a variable inside the RAM. So all the variables have one place to be stored at, the RAM, only the RAM. And sometimes that we call that memory. So far clear?
Yes.
Okay, then just now I show you something like that, which means that I show you how we can mix two variables or two things, but I did not show it to you with a string. So let me again explain this. I reserved a place in the memory for a variable that's called x. This variable is of data type string, which means that it will carry text at the end. And the text should be always marked with a double quotation as a start and a double quotation at the end. So far, is it okay? Is that clear?
Yes.
Okay. So as we know, a text is a number of characters concatenated together, or let's not use concatenation. It's slightly complicated. We are able to say it's a group of characters that is put together. Is that clear?
Yes, a combination.
Okay, that's good. Is it possible now in the same code that you have at the moment, are you able, so at the moment when you have, at the moment I ask you to make plus and I put 100 here, right? Am I right?
Yes.
Okay, so I would like you to replace that with an X. So remove the 100 in the same line, remove the 100 and put X. Okay, and then
Yes.
I would like you to write string X equal Alex, and then try to run that and let me know what is the result. So this is 1, we have to write it. We remove the 100 and put X.
Yes.
So you managed?
Yes.
Okay, and you saw Alex coming out?
Yes.
Oh, wow, that's excellent. So, okay, but did you understand what happened?
If I understand. Yes, I understand. Yes.
Okay, that's good. Okay. So let me try to skip this. Okay, so he's explaining only the advantage of using variables. So variable are able to actually make our code appear smarter, and it can make us reduce the amount of code that we write. So he defined here a variable called X, and it contains Sam. And when he wanted to print my name is, he doesn't need to write Sam again, because he knows that Sam is inside the memory and stored in a variable called X. So once he put plus X, so the Java will go to fetch out what is stored inside the variable X, or the position in the memory that is marked by X, and it will bring Sam and put it here and print it. And he can use Sam, the variable X, in any position. He can put it at the end, and he can even put it at the start, like here. So he say X plus is so cool. So again, since he know that X have no double quotation before it or after it, you see here no double quotation, right? So
Yes.
once he see no double quotation, he know that it is a variable. So he will search for it, and he will get its content and replace it with Sam, and then he will print Sam is so cool. Is this clear or confusing?
Yes.
Okay, so
Does this also save storage because you're using less characters, or does it still use the same amount of storage?
no, the storage is almost the same, but the
Okay.
only thing that you somehow no, wait, no, it actually save a little bit. It saves actually it's safe, because when you write X here, X only occupy a single character here, okay? So, and if you write Sam and you put it in a double quotation, instead of writing X, you can end up, if you didn't create this variable, you will have to write Sam here. So you remove the X and you write Sam like that. And if you write it, it could occupy more characters. But what is happening here when you write X, you actually replacing the storage by computational, you use more computational power. Because when you write Sam here like that, so he will just print it as it is. But when you write X, it means that he have to do more steps on the computational thing, which means that the CPU need to work more. So it will go and search in the memory for X variable, and it will bring its content and print it out. But we do not care too much about computational power because CPUs, the current CPU speed is actually executing 4.5 billion instruction in second. So you should not worry too much about power. You should worry about your time. Your time is more valuable than the computational power, especially in this kind of context. Does this make sense to you?
Yes.
So I just want to tell you that most of the time, your CPU, it is maybe between 10 to 25 utilization, which means that it never, I mean, most of the time it doesn't use 100% of its capacity. So you will never reach the need to run 4.5 billion instruction per second. That is very rare. Most of the time you are running between 10 to 25. And most of the time you will see that when we are running 100% utilization, you will find that the screen, the fan inside your laptop or your computer will run in a high speed, and you will hear the noise of it, and you will see a lot of heat coming out of your laptop. Did you ever recognize something like that?
Yes.
Okay, that's good. So let us move to the next here. I will not talk about that if you allow me, but I will only mention one thing. Yeah, I need to mention one thing here. I mean, we don't care really too much about advantages of variables, but I would like just to tell you, since you market, so you market the variable x of type string, and you inserted or saved Alex inside it. But the x, since it's a variable, it means that I'm able to change its content as much as I want. So what will happen that I will, if I do that line, it means take whatever on the right-hand side and store it to whatever on the left-hand side, which means that I will go to overwrite the text Alex that was stored earlier in X. So if you come here, you will find that we are trying to store inside X mystery date, which means that I overwrite Alex and I overwrite Sam and I overwrite Nikki. So the last line get executed will be saving. It will be the last data that is saved in X. So it means that you are able to overwrite the content of variables, and the computer will not remember the initial values. Does this make sense to you or no?
Is it similar? Because I think I've learned something similar in computer organization and
PHP?
architecture.
Uh-huh.
No, is it like last in, first out?
That is slightly different concept, but yeah, you can say like that, but just be aware that last in first out, it doesn't mean that. I mean, last in first out. How to say? Not 100% apply here, because in the last in first out, you will find that you're still able to retrieve the old data. Yes, you will get this out first, but in this specific case, you are never able to get Alex or Sam or Nikki. It will only remember mystery date. In the computer organization, if you're talking about stacks or queues or this kind of advanced data structures, you are still able. So it is, if you're having a stack and you inserted Alex first, so Alex will be here, and here Sam, and here Nikki, and here mystery date. Okay, so when you try to get something out from here, you will take the mystery date, which was the last thing inserted. You will take it out, but you will still be able, once you take it out, you will still be able to find Nikki and Sam and even Alex. But in this case, no. In strings like that, no. Okay, so that is one thing. And the second thing is, you are not able to do something like that. the variable name should be always on the left-hand side. You are not able to store X inside backwards. Backward is a text and it needs to be stored somewhere. So the correct thing is that we always put variables on the left-hand side. This is a variable. And we can put a value like that. We are not able to put num equal. We are not able to do that. This is totally wrong. This is acceptable. And this is also wrong. And this is acceptable. Does this make sense so far or still?
Yes.
Okay. Okay. So just bear with me. I think, I mean, you need to, since this is new, it seems new to you, please, I mean, you don't need to really clean all your code. You can just write in the same file at the moment to save time. I would say if you, last time you created an X and you stored Alex inside it, did you?
Yes.
Okay, so are you able to write just a system that print out X and that should print Alex to you, right? So if you write this immediately after X, that will produce, so I want you to write this line, just only print X. And then after you do that, you assign a new value to X. So instead of Alex, it will put Bunny. And then you try to print that out. So that should print Bunny. So the first print line will print Alex, and the second print will print Bunny. Can you do that? So 1,
Okay.
2, 3.
Yes.
So do you see the out? Okay, you understand, right? I can move next.
Yes.
Okay, so we have many data types, and each of those occupy a different, I mean, it occupy, how to say, different space in the memory, not different space, or I would say it takes different sizes from the memory. So okay, Boolean is actually a data type that allow us to actually store or have true and false. So any variable that is declared as, did you hear the word declare before?
Declare. I'm not sure.
Okay, it will come next, so don't worry. Just let us first know the data types here. We have 4 data types, 4 important data types. Okay, actually we have one more that is missing here, which is called character. So maybe it will come in the next slide. So we have Boolean, we have integer, and integers is numbers that does not have any decimal point. And it can be 1, it can be -10, it can be 20,000. So this is a kind of numbers that we consider as an integer. Any number with a decimal point, we call it double. Okay. And string, we already know. Alex is a string. Also, the string is anything in between double quotation. We are able to call it a string. So far, do you have any question before we move on? We still need to explain. Yeah, float.
Is float and double the same thing or different?
Exactly. They are the same thing, but there is something that is marking the float. And you also have to understand that double occupy more space in the memory than float. So if we have bigger decimal numbers, we prefer to be safe and use double data type. And I would say in 90% of the programs, we use double instead of float. Okay? So I will also show you in the next slides how we can mark the float and not double. Is that okay? Can we move?
Yes.
Okay. So if you see here, this is how he actually declare. So this, it is called, so this is a data type. We specify a data type, and then we specify a variable name. And this kind of line, it's called declaration. So I am telling Java, please go to the memory, reserve a place for me, and mark it with the name pool. And this place will be able to store values that is of the type Boolean. And the type Boolean can store only true or false. It cannot store 10. It cannot store Alex. Only true or false. So did I store any value yet inside the pool variable? No. So declaration is just telling that we would like to reserve a place, but we are not going to store any information inside it yet. The same goes to integer. The same goes to double. The same goes to the string. So when you say I'm declaring a string as Z, reserve a place for me that can take or can contain strings and mark this name with Z, but do not store anything inside it. So did you understand the concept of declaration?
Yes.
You cannot use any variables unless you declare it first. So you cannot store, you cannot say X. So this is X. You cannot say X equal 10 without putting first integer, I mean, declaring the integer. So you need to say integer X like that. So this is the declaration. After you declare, you initialize the variable to a value, which means initialization means you put an initial value inside the reserved place that is marked or called, or variable name that's called X. Does this make sense or is complicated?
It makes sense.
I think your understanding is dropping to 50%. Is it?
No, 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 it's not. It's I'm just testing it out as we're doing it.
Okay, so did you write it?
Yes, I was testing.
Excellent.
I was
Excellent.
testing without declaration and testing with declaration.
And did you see the errors that comes out when you don't declare?
Yes.
Okay, that's excellent. That's excellent. Okay, which can tell me if you are able to follow up with me in this way, it can tell me that you have a good capabilities. I mean, when you are able to listen and write at the same time and don't miss a lot from what I say, that is really amazing. I didn't see many students who are able to do that. So that is good. That's really good. So, okay, let me also tell you that we are able to actually save. So we can save time. We are able to do the declaration and initialization at one line, and that's preferable. So instead of just writing integer X and then writing X equal 10, we can just say in one line integer X equal 10. So this is declaring and initializing at one line. It's allowed. Okay. So instead of doing so like that, Boolean pool, and then you try to initialize pool to true, no, we can do that in one whole line, and that will save us time. But this is totally up to your preference. Sometimes students at the start does not feel that this is comfortable. They feel that they are comfortable with a simpler way like that. So stick to whatever way you prefer. Both of them will work. Both of them will do the same job. Is that clear to you?
Yes.
Okay, then we move to the next. So when we initialize a variable or declare a variable, like what we did here, x is an integer. So we are able to store numbers inside it. If we try to ever store a text inside an integer variable, definitely we will have an error. So can you please write this in your code and see what it will produce?
String cannot be converted to int.
Okay, so yeah, that is so data types, different data types cannot be mixed together. There is rules for mixing, but at the moment we cannot put a text inside an integer variable. Z is an integer variable, and we cannot store text inside it. Is that clear? We move to the next.
Yes.
Okay. So it is also similar here. I think we maybe, to me, let's just move to the next. There is more important things that we need to cover, if you allow me. So also, this is also not allowed. So true and false, it's of a Boolean data type. And we are not allowed to store Boolean inside an integer. Does this make sense? Does this make sense to you?
Yes.
Okay, so this is acceptable, but just be aware that if you make a mistake, so we have case sensitive in Java, which means that if you look at here and here, these two variable names are actually different. Can you recognize that?
Yes.
Okay, the V and the A is not correct here, right? They are mixed.
Yes.
Okay, so it means that this will cause an error here. So he will recognize that this is a different variable from this, and he will show us an error and he will refuse to compile. So far clear?
Yes.
Okay, so if you try, okay, one of the errors is that if you declare a variable and you try to redeclare it again, that will cause you an error. If we reserve a place for this variable, and this is of a double data type, we are not able to tell him again, reserve another place for the same variable. We are not able to do that. He will not accept that. He will consider this as an error. So if you try, can you try? Maybe? Can you try to do that?
Okay. Yes, it says variable double var3 is already defined.
Okay, so he does not accept redefining variables. Okay, but
Yes.
what if you have a variable like that and you did not initialize it? You declare it, you reserve a place for it, but you did not put any value. So if you did not put any value, it will not be possible that you tell the Java, please print the content of this variable. So this print statement will try to go and find whatever is stored in that variable and print it out on the screen. But you actually did not store anything. So definitely you will face a problem. So you need to do an assignment or initialization to that variable first before you try to print out its content. Okay, so you would like to try this?
I tried it, yes.
Wow, so smart. Okay, that's good. Good. Okay, so we are able to save. Let me move to the most important thing here. We are able to save our time, and we can declare and initialize 3 variables at the same time and do this kind of assignment. So it means that I'm initializing all the 3 of them just in one line. So I am reserving a place for variable double var1, double var2, double var3. All have separate places in the memory, and all of them will contain 3.1, but they are totally separate variables. Does this make sense to you? Or is it
Yes.
okay? Did you try it?
Yes. But
Wow.
is this ever necessary to give different variables the same
Um,
value?
Sometimes it will happen. Sometimes you might see it. So sometimes they initialize things. They would like to initialize variables to 0. So they don't put really the same value, but they just initialize it to 0. So sometimes they do that. But it is, I would say, yeah, I mean, you might 30% chance or 40% chance at maximum that you can see something like that. And
Okay.
also not very common in exams. They focus on other things. So
Okay.
um, yeah, so we need to take care a lot about putting names of variables, choosing the name of variables. The name of the variable should be tally. I should look at the name of the variable, and from it I'm able to tell what this variable is used for. If you tell me integer age equal 21, that should tell me what this variable is used for. If I say string address equal KL, that should, I look at the variable name, I'm able to tell what it does. Okay, so they don't really encourage to use variable that can have many interpreting. So X, I mean, yes, you declare it. Sometimes we do it fast as we put X like that, but I mean, from what I see, X, it doesn't indicate to me what is referring to. Is it referring to an age? Is it referring to a number that need to be multiplied? Is it referring to Celsius? Is it referring to USD? So we don't know what this X is actually is. So when you write a meaningful thing here, then you can able to understand. So did I make sense? Does this make sense to you?
Yes, it does.
Okay. So okay, variables cannot start with numbers, which means that this is not allowed. Numbers, you can put it at the end of a variable, is acceptable. So if you have hacker, so if I say Boolean or even integer, hacker123, this is okay. But you cannot put the numbers before the text or before the characters of the variable name. So this is not acceptable. Also, it is not acceptable that you try to redefine the same variable name with different data types. Also, that will cause problem. Okay?
Yes.
Okay. So this continue is a reserved keywords from Java. So this continue, we will learn how to use it later. So we are not able to use it as a variable name. Okay, you cannot tell me integer static equal 10. So static cannot be a variable name because it is a reserved keyword for Java. Is that clear?
Yes.
I'm sorry, I'm rushing. I know that.
No, it's okay. It's a good pace compared to class.
Okay, so I think here is okay. So like you see here, that is a very good way of actually naming variables, because okay, variable name normally start with a small letter. Okay, this is a variable name, not the class name. Class name, you can put the first capital So compute, and then he say expression. So this we say public class, and then we say compute expression. So here capital and here capital, but we're talking now about variable names. This is slightly different from here. So variable name normally start with a small letter, but if you would like to concatenate it or put it together with another name to clarify what we are going to use the variable name for, so I can just put age, but he would like it to be specific. So he say student age. He would like to make it clear. I mean, if he put the A as a small, it will still run, but it is more obvious to us and more catchy to the eye that when we put capital letters here, like this. Does this make sense? So you see here, he start with a small letter. He say my, this is a separate word, and catch is a separate, so he started with the capital, and P is a separate word. So my catch phrase or phrase. So the P here capital, the C capital. If you put it C small, P small, it will still run. There is no issue here, but this is a recommended practice.
It's like a grammatical error, so you can read it more easily.
Yes, yes, you can read it more easily, but we wouldn't say that this will produce any error or even warning. No errors, no warning. Okay, clear? We move to the next. Okay, so this is a summary. I would say that we need to start with lecture 2.2. So there is certain parts that I'm not able to skip at the start, but later I think I'm able to skip parts. But I mean, especially this slide lecture 2, all of it, I need to still explain things, because if I jump those, we will end up not in a nice situation when you come in the middle and you become blur. So does this make sense to you? Is it acceptable to you, or you would like me to try another way?
Whichever way is more, how can I say this? Like, I don't know, like before I was saying I learn better through the practicals. So I don't know if you can get enough time to explain things if we're doing the practical exercises, because the practical exercises are very specific. So I don't know if that's can help.
So okay, let me think, because there is a lot of theoretical background and details that need to be explained to you when we are solving the practical. So you will not be able to understand the practical if I don't really, I mean, let me give you an example. So, okay. So this where, let me see. Okay. So this is one of the practical things that you gave to me, right? That you told me that, okay. So if I would like to actually explain this, let me just try to print. I don't know why he is pointing it out. Okay. So if I try to explain this, okay. So at the end, okay, this, I need to explain to you what is P minus minus first. And I need to explain to you what is plus plus B first, before we are able to execute that and tell you what is the print statement. And that is not so difficult. But so there, I mean, yes, we are able to solve. If you prefer like that, we can, yes, I can stop explaining the slides. Of course, I'm not able to explain all the slides. That is very clear to me. What I wanted to reach, is that just a basic understanding first, to make sure that you have, what is the variables. I mean, when we use this kind of thing, you need to know at least what is the variable. So that is the basic things. But if you would prefer, we can go through this first. Yes, we can do. But
like if we don't need to do this one specifically because this is, how can I say this? This is something similar to what I'm going to do in the midterms. But because I didn't understand the previous practical lessons, like the ones that I put in the folder, it
Aha.
goes from the basic ones to the more advanced. Like the first practical lesson
Okay.
is something simple, and then it keeps getting advanced as we go. So
Okay.
I don't
So
know if that can be
what do you
easy.
think? So what do you think? Should we? I think then I think that is maybe a better way. So maybe we try to solve the initial exercises first, and then
Yes.
we move on until we reach that level. So okay, that makes sense. Yeah, we can try to do that.
Because I think like in the practical, just like you had, like just like you're saying here, even in this test question, when we will be talking about it, we you can still explain what this specific thing means without having to go to the slide.
Well, it will be better to go to the slide, to point out to the slide. But yes, we can do it without the slide. Definitely, yes.